Exactly.
Mm-hmm. Hello.
Hi.
How's it going?
Good.
Yeah.
Snow.
It wasn't. We talked about this before. It was not snowing outside. It was falling slush. It was not. No, it was not slow. It was just like really big clumps of slush, which is even worse.
How are you?
I'm fantastic. Fantastic.
Episode 5.
So this is the last episode before a little bit of a winter break.
Yeah, we're going to do a Christmas break. We'll be back in early January. But we've been covering a lot of the basics now. And then let's look at a bit about project structure and how we can scale our project. Because now we've been doing only one file. Nothing else.
What?
Yeah. And now we want more files.
Oh, no.
And then we want stuff all over the place. And yeah.
All right.
So some of the puzzle pieces that might have been a bit confusing early might make more sense now.
We're going to get into that in a second.
Yeah. Let's go.
And go over to you.
Mm-hmm. So struct Gabe, bool hash greeted. Then we have a constructor called Gabe, and then a function bool called hi. We implement the constructor of Gabe by saying hash greeted is false. And then we have a Gabe hi. So, hi Gabe.
Hello.
You good?
Yeah.
Yeah?
Yeah.
That's good. So, last week we looked at classes. And you got a bit of homework.
Yeah.
A little bit.
Yeah, we're going to talk about that.
We're going to talk about that.
Yeah.
Just a little bit of homework.
A few tables were flipped.
A little bit.
I think a hole is in my screen.
Yeah. This week we're going to look at C++ itself, the language. So we're going to learn about that. It's how projects are structured, how files come together, how they're linked. Because it's initially not very intuitive, but I hope that I will give a little bit of clarity into it, and then we'll play with it. And yeah. So ready?
Yeah.
Yeah. So homework review.
I realized I didn't adjust this camera, by the way.
There we go. Mm-hmm. So we have these. You have the answers. We won't swap over to you. I'll just have mine because I have examples for every one of them. Okay. So could you use all types as member variables of a class?
Yes.
Yeah.
Yeah.
Yeah. So you can make some class. You can have Boolean, an int, HR, a float.
I forgot about float.
Yeah, you can use a float.
Stop using float.
Yeah. You can't use void. Not as a member variable. No. Not straight up void. But yeah, you could make a class that has all these things in it. So that's fine. So, can you use all types as return variables of class functions?
Yes.
Yeah. So, if I have a class and then some member variables, then I can say some bool function, some int function, char, float. And here I can also say void. So here I can actually use void. And why is that? So what do void functions return?
A number.
A number?
They just return something, right?
No.
What do they return then?
Nothing.
But they do return something.
If they just do return, but nothing after that.
Oh.
Mm-hmm.
Okay.
Yeah.
I didn't know. I thought they just returned whatever you wanted.
No.
Oh.
They return nothing. You just say exit, basically. So you can have Boolean, some class, some bool function, then you have some code, but then you return a Boolean. If you have an int, you do some code, then you return an int. You had a case where you wanted to return a char, so the type was like char, some class, some function, but you return an int, and you were talking about like why, if that was okay, and in cases that is okay, but you might know that you are converting, so you are turning an int into a char. That's not okay because int can store more. Like you can store the number 1 billion in an int.
Yeah, but char can only go up to like
255. Yeah. So if you were turning a char into an int, that's totally fine because a char can totally fit within an int.
But an int might not fit in a char.
Yeah. Cool. Can a class have no member variables?
Yes, but that's pointless.
It's pointless? Yeah. It's like this. So struct. What's my purpose? I have an add function in there. Takes an A and a B, and then I implement the add. This seems to be just an extra overcomplicated way because I have no member variables to reference. Like if I want to use a variable, it has to be sent in. There's no way to use anything. So even if we would have a struct that has no member variables, and I would have a function that would take in no variables, it would be empty in the parentheses, what could you do? Not much.
Yeah.
You just say return 4.
Easy.
Easy.
Quick math.
Can a class have a member variable of another class?
Yes.
Yeah, that is correct. So here, if I create a class called buffs, and then I have a couple of buffs. Here's the double damage buff, the invulnerable buff, like if you have them. So it's a Boolean. Do you do double damage? Are you unkillable? Are you invisible? And then you might have some constructors and functions. So then if you have the enemy has the health, enemy has the damage, but then also enemy has the buffs. So I would call it the active buffs, because.
But you would have to name it somewhere else to be active buffs. Like there would have to be a function somewhere that's active buffs, right?
So in 9.14, I'm creating a variable called active buffs of the type buffs. There would be a function somewhere that would create the buffs and set them and all that. Yeah, totally. But then when you're doing the damage, you can ask the active buffs invulnerable, if that's true or false. Yeah. Because then when the damage comes in, you first ask, hey, is active buffs invulnerable? Then you just exit the function, because you're not going to do any damage.
But when, this is just an oversimplified, okay, some constructors and functions and stuff. Okay, got it.
Yeah, it was just a case of, can you have a variable that is another class? Yeah, line 14, you can do that. Can you use a class type as an argument into a function? That was a bit of a question earlier. You also had because you were so used to sending in ints and booleans into functions, but then sending a class into a function.
I wrote yes.
You wrote yes? Yeah, that was correct. So if you would have buffs again, and then you have an enemy, and then you would have a function called activate buffs. And you can actually then send in buffs. Like here are the new buffs. And then you can say active buffs is equal to new buffs. There is a bit of a catch for line 19. This would work, because what you're saying is, if you would have an int, you would say this number is equal to this number, right? But with active buffs, it's a struct, it's a class. So you're saying active buffs is equal to new buffs, which means that all the booleans in active buffs should be the same as all of the booleans in new buffs, right? You're not just saying active buffs is equal to new buffs. You're saying active buffs double damage is equal to new buff double damage. Active buff invulnerable is equal to new buff invulnerable. You're setting all the booleans.
But this is basically... So the question was, can you use the type as an argument?
Yeah, you could send that in. Yeah, you could do that.
That's and then in this case, but what's the type that we're sending in buffs as the type? And we're naming new buffs. The actual function of new buffs just doesn't exist on this, right?
New buffs is not a function. New buffs is a variable.
Okay.
You can see on line 14, the function is called activate buffs, but what we send in is called new buffs, which is a variable.
But then at the bottom, at line 17, we're saying that activate buffs is new buffs. Or line 19 is saying active buffs is new buffs. See that? Now I'm back to where I was before, where I don't see how those are connecting to each other.
So this is just an idea that if someone calls this function over here, they have to send in
new buffs.
A buff, a variable type buffs. It will be called new buffs in here. But we don't see the user. We don't see who is actually using these functions. That's somewhere else. So we're creating, this is usually called creating an interface. Like, you don't know, like when you design a steering wheel, you know that it's going to look this way because it's going to function, you can turn it. You don't know who's going to use it. But at least you've designed it in a way that you can use the steering wheel. In that sense.
Don't make steering wheel square.
Sure. Okay. Can you use a class type as a return value of a function?
Yes.
Yeah. Yes. So here we could have a function called getBuffs in line 14. And then we just return active buffs. And then, so the function is returning buffs. In an older style of C++, you wouldn't do this. You wouldn't return a type like this. But there has been updates to the language where this is okay. Like you could do it, but it was more expensive. It would take more cycles to do this.
I like the idea of updating languages.
Yeah.
We haven't done that for a lot of languages in a really long time.
Yeah, there's a lot of languages that don't get a lot of updates.
No.
There's some that do. C++ gets one every 3 years. Yeah.
That's pretty good.
So
Imagine if we just remade English every 3 years.
Well, it's always evolving, right?
I mean, is it?
I mean, you get new words coming in. There's the dictionary always adds like, oh, the new word of the year.
What was the word of the year last year? As we go on a little tangent, it was something real dumb.
I don't remember,
what
what
it
that
was.
No, but usually like a popular culture.
Yeah, they're really disappointing most of the time.
But they're saying that it is used enough that like they see it in printing presses and books and stuff. So it's not just me and you saying "pog" or something.
That's what we should add to the dictionary. Pog champ.
Yeah, exactly.
Let's go.
Great, cool. So, you had then, if you go back, you had a solution.
I do.
To
the question.
Yeah.
Do I put it in here?
Yeah. Let's switch over to yours.
Okay, hold on.
Mm-hmm.
It's longer than I expected.
Because I saw his solution.
Well, yeah, you helped me make it.
No.
Yes.
You asked questions and I answered them.
Okay. No, I had no idea what I was doing. So I take no credit. Oh, we're dropping frames.
A couple of... It seems to be
we'll see how it goes.
Yeah. So you called it homework.
I did. But I had no idea what I'd do. Before we even get to this, I completely failed every aspect of this because I had absolutely no idea what I was doing. I had so many questions, and there's no way I would have done this if you weren't there.
Welcome to learning.
Yeah, well, you know what? Anyway.
So you called it homework?
Yes.
It stores a letter and the question of is it uppercase or not.
Yeah.
And
then we needed to make these
3 functions, and then you had the constructor.
Yes.
So take us through the constructor first.
So
if I would send in the small letter A, what's going to happen?
It goes here.
Okay.
Doesn't it?
So what happens in line 15?
Well, we're saying that letter, which is defined. Wait, where's letter defined? Oh, it's here. That now it's equal to a letter, which is this. If it's greater than or equal to 65, which is small a, I think.
Is it small
or it's
a?
big A.
Big
no,
A?
it's big A. Because, and then if it's less than or equal to 90, which is Z.
Yeah.
I think.
Yeah.
And then return is true. Or, well, return true to is uppercase, which is this.
Yep.
And if not, return false.
Okay.
So this was the first... No, this was actually one of the last questions. No. We never had this as one of the questions that we had to answer. But it was to make this useful.
Yeah. It's
But it
uppercase.
was also show that we were changing the lowercase and uppercase of the letter depending on what we were sending in.
So let's then go through make uppercase.
Yes. So...
What does that mean? So if I created the class with the letter big A, what does that mean? If I call make uppercase, what happens then?
Nothing.
Nothing.
It just returns false because it's uppercase already.
Yep, exactly. So if I send in a big A, if I send in a small b,
it would go in here and be like, oh, make uppercase. Yes. It would minus 32 from that on the ASCII table and then make it an uppercase.
Yep.
And that would return true. And then would return true again for some reason. Why do we need to return the second true?
Well, we return true there.
Yeah.
No, return means exit the function as a true. It's uppercase. It's just setting a value.
because it's a bool. It's a bool. Okay, yeah. Sorry,
Yeah.
I wasn't connecting that in my head again.
No, it's fine. Okay, so set letter. What's happening there? The next letter.
Next letter, yeah. So we're asking if the letter that we send in is greater or equal to 65 and less than or equal to 89, which I think is the letter before Z. So X, Y, no, not X. Or, no, yes, that's or, right? If the letter is greater than or equal to 97 and the letter is less than or equal to 121. So this is asking the question, is the letter between capital A or capital Y? Because if it's Z, then it will be pushed out of the alphabet.
It'll go beyond. Yeah.
So it can never go beyond that because we just stop it before it gets to, I think it's like one of the brackets after a capital Z.
Yeah, because that's an edge case. Because when you started, if you send in small a, and then you say next letter, next letter, next letter, keep doing that. If you would go to C, and then you call next letter,
it'll go into not a letter.
Yeah, which we didn't want to do. So that's an edge case. That would be, well, if you would have done it the normal way, that would be a bug, right?
Haha.
So you
didn't exist.
You thought about the bug, which is great.
Well, I thought about it because I did the
You went through it.
debug and saw, oh, wait a minute.
There you go. Using the tools. So there's one bug there. Because it's returning Boolean, but you return letter. Letters of type char. So what you would do there in line 42, you would say return true there, and then after that return false. Exactly, because you didn't do anything.
Yes.
Yep. Then set letter.
Yeah.
So
which is just saying.
Yeah, that's an interesting one. So set letter is exactly like what?
The constructor itself.
Yeah.
It's the same code.
Yeah, because you want the same thing to happen.
Yeah.
When you set a new letter, all of the you not only set the value, but you do then something else. You do the whole are you uppercase or not.
Yeah. But basically this makes everything else pointless. Because now we're just setting the letter to whatever we want it to be.
Yeah, but what if you're done, you did the thing, whatever the thing you wanted to do. You set the letter, you did the thing, blah, 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 you set the next letter, now you're happy, and then you want to reuse it without making a new one. You could just say set letter.
So what would that look like in a practical sense? Like,
well, it could be a case of, let's say this is some sort of, let's say it's a DPS calculator that you have here, and then you give it a player, and then you want to calculate the DPS, you do the DPS calculation, whatever the thing you have to do. But what if creating the DPS calculator the first time is expensive? It takes a lot of cycles to do.
Yeah.
But reusing it is not expensive. So you could say like, oh, I'm going to use it, give it the player, we'll calculate the DPS, we're happy, happy, happy. And then you say like, oh, I need to calculate someone else. So instead of remaking it, you could reuse it by just, hey, here's a new player. Reset everything, let's go.
Okay. So this is basically, this is the last thing.
Yeah.
If we want to, so the way we've written it here though, it always happens. I guess in a more useful program, there would be some condition that says go to this one.
Yes.
No, because right now, I mean, when you run this, if you put a debug thing on every single one, it's always the final result will always be whatever we say here.
Yeah, because the use case, which is in main, it doesn't make sense. But you're using it to test it out. Yeah. Yeah, but if it would be like a regular scenario where you're using the code.
Can we ask like an if question here before this happens?
Oh, sure.
Okay.
Yeah, you can do whatever. Like all of the things you learned before, you can a while loop, an if, you can put this in a function. All of these apply. Like all of these are building blocks that we can then Lego together. Like very few of these things are exclusive of each other. So like you could use, that's why I kept asking the initial questions in the homework. Like, can you, like asking you to try things out and test things out just to explore and see that, oh, I can actually use an if statement in a function. Oh, I can actually use a while loop here. I can use an if statement in a while loop. So you can see that these things are actually mixing together. Cool. So let's go back to mine.
I got an F.
Gabe.
I'm giving myself an F. Can I delete everything here?
You can do what you want.
Freedom!
You can do what you want. He did not get an F.
I did.
No. That's a good. The only error was that in one function. That's like a B+.
No, that's not a B+ when the teacher did my homework.
No. No, I came over like twice and you asked a couple of questions. Oh, Gabe. Oh, Gabe. Oh, yeah, we're back to mine. Yeah, so C++ project tester. All right. So we've currently been dealing with one file and one file only. And we need to break out of that mold, if we think of it that way. So currently we've been doing this. This is the idea that we've had in our heads that there's some file, .cpp, and then we hit our magical F5 button, and this happens.
Yay!
We get a file.exe. And then in between, magic, right?
Yep.
Absolute magic. So I would guess it wouldn't be shocking to say that it's not that simple. Of course it's not. My whole life
has been a lie. I thought it was done. I thought we figured everything out. And
press button.
Yeah.
Of course. Computers were made with F5 button and then magic, right? So no.
So if I go home and spam F5 today, it'll just mold a new computer for me. Perfect.
Of course. So it would be a hint if I move the box over there that there's some more steps in the way. A little bit of
No,
a
you
hint.
just hate order and structure.
Yeah.
You're just like, you go over there, the next one goes on the bottom.
So there's a thing called, so the green ones are, you think of them as systems. So the gray one is the actual file. First it goes into a thing called a preprocessor. Then it goes into a compiler.
Okay.
Mm-hmm. You've heard of that before?
Yes.
Then it goes into an assembler.
But this is all automatic, isn't it?
So Visual Studio, the tool we've been using, when we press F5, it does all that.
Ah, easy. See, we do build with just F5.
Yeah.
I don't know what you're talking about.
No. I mean, we've been doing this. This has been happening.
Yeah.
Like when we hit F5, this happens.
Yeah, perfect.
Perfect.
It's all there already.
So we go into a preprocessor, then we go into a compiler, we go into an assembler, then we go into a linker, and then we get a file. Cool. So
I just see Visual Studio right there in the middle.
green is Visual Studio. Great. So we're not going to look at all of these. Today we're going to focus more on the preprocessor. We might look at a little bit of the compiler, but that's later on. That's just for the assembler and the linker. We're not going to look that much into because those are more niche kind of subjects of why they're happening and what they're doing. But the preprocessor is important to know about, and the compiler will be a bit later on. So we're going to look into preprocessor. Yay, graphics. So normally you have this. There's a main CPP. It's just your file. We've been doing that forever. So if you have another file, let's say enemy.cpp, and the idea is to separate out code. We want in the enemy file only to be the enemy code. So it's much easier to maintain. The file doesn't get big. We don't want thousands and thousands of lines of code. We just want, like I say, hey Gabe, can you fix the bug in the enemy code?
I got it.
You got it. You just open up
where it is.
You open up the enemy code. You just work there.
I know where it is because I don't write bugs. I only fix bugs.
Yeah. So you don't have to look at the inventory code. You don't have to look at the everything else. All of the systems don't care because the bug is in enemy. Great. So we want these separations, but still, there's only one main file, and let's say we put it in a file called main.cpp. It doesn't have to be, but we can do that. So it is in main.cpp. That's where main the function is. So we want main to use the enemy code, right? But they're in separate files. So how do you do that?
Probably by saying something about the file name and then calling something in it.
Yeah. Yeah. So what you usually then do is you create a header file, or .h, not cpp, .h. And you put some of the code in enemy.h, and then enemy.cpp uses that file. So we actually have 3 files. And main.cpp also uses the same file. So
it's more enemy H now is controlling what the enemy is.
So enemy H is remember when you're writing classes, you have the 2 parts. You have the struct, that stuff, and then you have all the functions, the actual function itself. In enemy H, you put the struct.
Yeah.
And in enemy CPP, you put the functions.
Yeah. So enemy H is more like the framework for what needs to happen with enemy.
Yep. Like enemy is going to look like this. It's going to have these variables. It's going to have these functions. How are they implemented? Main actually doesn't care, right? Main is like, hey, I just want to know how it looks like. I want to know what the name of them are. What do they take? Somebody else is going to implement them. And then I'm going to trust that's okay. And what happens is when you're compiling is that there's going to be 2 files that are generated. There's going to be main.o, usually what's it called? It's an object file. And then enemy.o. And then those 2 O files are then combined into one CPP file. But they are 2 separate objects. So don't think of, like, CPP files usually don't mix. Or basically generally don't mix. So it usually looks like this. You have enemy. It has whatever the things we made for it. It has health and damage, has a constructor, has some function. Enemy CPP. So you'll see on line 1, this is one new thing, right? So we'll have include enemy. So what this is saying is, there's a file called enemy.h. We want that file to be here. And what this actually is doing is, this is literally copy-paste.
Nice.
This is actually include enemy H means take what is in enemy H, copy it, and paste it on line 1.
But without taking up all the space.
Yeah. So
just saying read that file first.
Yeah, and that is what the preprocessor does. The preprocessor does quite a few things, and this is one of the big things it does, is any kind of like these hash values, it says include, and then here's the file. So now you might kind of see why we split things up, and why I started teaching the classes in the split way. Because they are separate, and they should be separate, because they're going to end up in a separate file.
It just makes it way easier to understand exactly what the enemy is and what the other stuff is.
Yeah. So enemy struct, that goes here. This is kind of the description of it, how it looks. And here in the CPP file, that's the actual code, the actual function. So in main CPP, you also say include enemy H. And there, you
now we have the main.
And look how small the main file is.
Small?
Very small. It could just says, hey, there's a file called enemy.h, and then I can just use it. Now that's great, right? And yeah, Nemesis has easier as a team to work with a structure like that. Because then, if I'm working on main, doing some code there, and you're working on enemy, we won't clash with each other. We can work on the code separately.
Oops, sorry. I forgot to mute my phone.
Mute your phone.
I'm expecting a call from my landlord.
Getting kicked out?
No, my elements, the heaters, sound like a waterfall when I turn them on. So I'm like, my apartment's real cold now because I like to have my ears.
Yeah.
Anyway.
Yeah. So another way of thinking about this is, so if you think of them as, so one way of thinking about them is in this kind of diagram. Another way was the copy paste. Think of includes as a copy paste. And another way is do it like this, where if you have enemy H and enemy H in both of these files, that they are both there.
Yeah.
They are duplicated. And that can actually bring problems because a thing is only allowed to be defined once. You can only once say struct enemy and then put in all the things. You can't do that twice. But since there isn't a case where enemy is twice, if you think of this as like a diagram flowing down, enemy.h won't happen twice. But there are ways to mitigate that, and I'll show you how to do that. But yeah, you can think of them as main is on this one side over there, and then enemy is further in. And since they both say include enemy H, you can think of them as above. But they're twice and they're linked like that. Okay, so let's look at that. Homework.
Homework. That was fast.
Time up. No.
Go over to your double.
Let's go with the double. Not that double.
They both say double. Look, now I'm in a different angle. I'm so small now. Hello.
Gabe has been playing with the camera all day.
Yeah, but I wanted to fix. All right, I'll just set up a little bit.
Yeah.
There you go.
Okay, so the only thing we're going to do today is to look into adding a couple of files. Maybe make a struct, include it, and then play with it that way. All right.
I will make my screen make sense.
Mm-hmm. So let me move a thing in here. That
Cheater!
I'm going to move it. You don't have to dock it like this. So this is the source solution explorer. So this is the project that we have. And here we have the source files, the actual C++ files. So if I say here, I want to add a new item, and you can do the same on your end. It just won't be as visible, I think.
Sorry, I missed the first step.
It's fine. Where it says source files here.
Oh, I didn't have that open, so I was like, well, I don't know what is it.
It's a solution explorer. If it's not there, it's view and solution explorer.
Okay.
Mm-hmm. There it is. Cool.
So, whoops. How do I get it to do the left side thing?
On the plus docking thing that's happening there.
Here?
The thing on the middle of the screen? There's like this plus in the middle of the screen. Oh, you can do that. Yeah.
Close enough.
Yeah, sure.
Oh my god. Okay, I got it. Yeah.
Got it. Okay. So if you right-click source files and hit add, and then you can do new item.
New item.
So it will say, hey, do you want a header file or a CPP file? So let's create a header file to begin with, and let's call that enemy. So that will be enemy.h. And do them lowercase. Yep. And look what it does. So it says pragma once here. And again, if it starts with a hashtag, it's most likely the preprocessor that's doing that. And this is preventing the multiple include problem that might happen. So just ignore that. That's okay. If it's a header file and it says pragma1, that's okay. That's it. It's just avoiding the problem of a file because you might include a file, and that file might include another file, and that file might include multiple files. You see the chain that might happen. So you might get a diamond problem where like files are including the same file twice. Like you might have in a.h, you might have include b.h, and then in c.h, you might also have include b.h. So both of these files are included b.h, right? And then you might have files that include both A and C. Like you can have main.cpp, and that one might include a.h.
But then you have like double b.h everywhere.
Yeah.
Okay.
And then you say, so A includes B, C includes B, and main includes A and C.
Yeah, so you have
B twice.
Yeah.
It's just preventing that.
Okay.
Yeah. Because again, it's copy-paste. So B will be copy-pasted into C, B will be copy-pasted into A. So when you include A and C, B is actually copy-pasted twice into the list. So this is just saying, don't do that. No.
Don't do it.
Don't do it.
Don't do it, or I won't let you do it. Or I will save you from doing it.
I will save you from doing that.
Okay. Thank you, Pragma once.
Yeah.
Very good. Thank you.
This is Visual Studio saying like, because the Visual Studio will create the graph, will create the tree, and see like, I only need it once, so I'll ignore that. So if we create here struct enemy.
What zoom percentage are you at?
1,000,000, not 200.
1 million. How
1
did you
million.
do that? Okay.
Yeah.
Sorry,
yeah. Dag was talking about the if and def. So there isn't a standard way to do this. The C++ standard hasn't said like this is how you do this. There is a way to do the if and def way where he described it in the chat. You can do it that way. I feel this is simpler and it works on most of the compilers. So
I'll take simple.
Yeah, I'll do it that
Just
way.
like me.
But note that there's another way to do it, basically.
My keyboard's in the wrong language.
so we say struct enemy. Let's just give him health and damage, and then let's give him a constructor that doesn't do anything for now.
Bam, the best kind of constructor.
Yeah. So he'll say here like, hey, I don't have an enemy. You haven't made the actual thing. So let's go back to the Solution Explorer.
Oh, gotta open that again.
Mm-hmm. And let's add a file. And let's add main enemy.cpp. Yep. Okay. So you'll have a new file there. So in that file, so in enemy cpp, it removed the pragma ones because you clicked on header file, but you named it cpp. It was just adding pragma ones into it.
Oh,
you can just delete
it's right there, isn't it?
Yeah, it should only be in header files.
Oh.
But
okay, yeah, because
you clicked on header but named it cpp. It's fine.
Fine. They didn't even notice.
It's fine.
Okay.
Yeah. So here, if you say include, you say enemy aids. I love how you write include.
Listen here. Okay. I can't type.
It's fine.
I swap between keyboards too often.
Mm-hmm.
So my hands are just confused now.
Mm-hmm. Good stuff. So now we can then think of that the struct that's here. It's basically, this is saying copy,
paste it there.
Paste.
And now we can do functions.
Yeah, so now we could do enemy, we can make the constructor. There we go.
Oh, nice plus there.
Thank you.
Sorry, I need to take jabs where I can. I don't have many of them. No.
So here's the thing that people find. So now you have, let's say this is a big class, and you're like, oh, what was the name of the variables we made again? Like we remember it because we just made them.
Health and damage.
Health and damage.
Yeah.
So what some people do is they don't name them health and damage. They'll say my health and my damage, right?
Oh, Hamish, stop subscribing. I'm just going to call him out on that. Nice, Hamish.
So if you say my health and my damage, now when you go here, to CPP, and you type in my.
Oh,
Well, you didn't do that. If you type in my, you see what happens.
Yeah,
you get numbers, yeah. There's another way, because we talked about in an earlier episode. There is a variable within the class called this, but then you have to do this and then an arrow, and then you get them.
Okay.
Yeah, we'll go into what this arrow means later on.
What does this do again?
This is
telling you this is this.
Yeah, this. When someone calls it, it will be this object. Yeah. So some people do this. Some people might do m underscore. So you do.
But it's just a naming thing.
Yeah, because then
just to make it clear that like this is assigned to something.
Yeah, because if you then say int a damage.
Yeah.
Right, and then you have. Let me just fix this here. So let's say the constructor takes in that. We have my health and my damage, m health and m damage, and then it's 8 damage. It's easier to. There you go.
Because now we're telling it just in the structure of this. We're telling it that the variable is an int that's called a damage.
Yep.
And we're just transforming m damage to be a damage.
Yep.
So my damage is now whatever we set a damage to be.
Yeah.
Okay.
Yeah. So it's just a way of saying like this is going to be a member. This is the argument. Again, these are just names.
Yeah.
We can name these whatever we want, but it's just.
Should have named them like I did my homework, but we won't talk about.
No, we won't talk about that.
Maybe the post show.
Maybe a little crude language. So
my frustration came out in my naming.
So, yeah. So we have these like that. Okay. Why is he yelling a bit now? Oh yeah, it's because I haven't initialized both of them. But anyway, so if we do this, let's just do it that way. It's okay.
I'm a bit behind.
It's fine. So if you do, let's allow the constructor to actually initialize both values. So
call mine M.
Yep.
And you put a damage here. You put a damage, right?
It will be int a damage.
Oh.
And then int a health. I think we had it the other way around. So let's do health first and then damage.
Oh my god.
So it's health and damage, health and damage. So I can copy this one over to here. So again, I have health and damage. And then I set health to be a health.
Then I do this int a health. Then it'd just be one day. It's just a health. Yeah, okay. Because
it will be matching. Cool. So again, these are just standard. Like, or these not standard. These are just like this will be different from project to project. What people think. Some people will do it like this with this arrow. Some people won't. There is a case where you have to do this.
My damage is not happy.
Is it called m damage in the header file? Or you just haven't saved? You called it d damage. Oops. Yep.
Got him.
Yep. So there we go. But yeah, so these are just ways of doing this. There is a way where you have to do it like this. We probably won't go into why that is, but it's there's one case where you have to do it like that. But these are just coding styles. Every project has a different one. I remember that I really didn't like the Uplay coding standard when it started, but now it's my favorite one. I can't use anything else. So, and I think also like arguing over styles is kind of petty.
I don't like your shoes, but I do.
Yeah, like it's the main important thing is, are you consistent? Is it the same all over the place? If it is, wonderful. Because then if someone joins a team or is reading code they haven't read before, it's going to look the same. So if you use one style over another, it doesn't matter much. Just be consistent. Any kind of argument is, I feel, kind of shallow. Yeah. Okay, so we have the file. Enemy, m health, m damage, a health, a damage. Exactly. And then we have a constructor and it sets the values.
Oops.
Great.
Pinned it.
So here then in main, we would have to then say, what do you think?
We'd have to call this.
Well, we need to get this right into the game CPP.
Well, it depends. What do we want to do with it? Do we just say? Wait, let my brain cogs spin for a second.
So remember
we need to put M health in there, right?
So remember how the structure was? It was kind of a triangle in that sense.
But right now we need it. But which one do we need first?
So CPP files never connect to each other.
Okay.
And you can see that in enemy CPP, we include enemy H.
Okay.
Okay.
But then in game CPP, then we need to do the enemy. This.
Well, we need to include again.
Oh, okay, yeah. Well, there's that. Oh, I thought we were talking about between the brackets. I mean, no. I wouldn't have figured that out anyway. But
I'm sorry. I should have been clearer.
I wouldn't have gotten it anyway.
It's great. So, again, we have the little, think of it like a pyramid structure, where game is including enemy H, and enemy CPP is including enemy H.
Yeah.
But what's happening is you have the main file, the game.cpp, that will be turned into an object. And that object will include a function called main, right? And it will also include this structure. But we haven't, if you think of it from main's point of view, from this file's point of view, like let's ignore enemy CPP. So we have a function called main. That one is implemented. It doesn't do anything, but it's implemented. We have this enemy.h file. It's a struct. It has two variables here, and then a constructor. But it's never implemented. The implementation of the constructor is here.
Yeah.
But from game CPP's point of view, it doesn't exist. Because game CPP includes enemy H just as this. So in this world, there is no implementation of enemy, the constructor, right?
Yes.
Because that's the chain. Game CPP goes up to enemy H, that's it, you're done. So
that doesn't seem right.
Yeah, that's correct. That's why it's kind of counterintuitive. That doesn't seem correct. And in the enemy's world, there is no main.
But how do they talk to each other then?
So that's why there are these intermediate steps in the compilation. So if I go real quick back here.
Oh, you need to go to you.
Yeah, sorry. If I go here.
Yeah.
So you have the file, which is then processed by the preprocessor. That's the hashtags, the copy pasting, all that kind of stuff. Then it goes to the compiler. The compiler will create the assembly basically, and the assembler will turn that into basically object code. So after here, we have a file called game.o and enemy.o. We haven't actually made the actual exe yet. So here in the linker, will you take all the O files together, combine them into one big blob, and then and only then do you actually need to know about all the other functions.
But how do we tell them that they're this? Like, how do they find out about each other's functions?
They're trusting us.
Oh God, don't do that.
Yeah, they're trusting that there's going to be, from this point of view, like, oh, there's an enemy H, great. Here's a class of an enemy. Here's a constructor. I don't know about the implementation of the constructor yet, but I'm guessing it will show up eventually. So, and the same thing for here. Enemy CPP, I have an enemy. Here's the constructor, enemy H, cool. There's no main, but I'm guessing that's going to be somewhere.
But because main will send in the value, right?
Yeah.
We assign the value in main.
Yeah.
So how does the other things know what the value is?
So
if there's no link between them. So if I assign here, like, I don't know, what can I assign here? Like,
if you switch over to the double thing again.
Yes.
Sorry.
If I assign, so what would the structure be here if I wanted to assign one of the variables to do something?
So yeah, so here we can say enemy. Sorry, let's call it Gabe.
Yeah, like enemy dot. Oh, okay.
Yeah, Gabe. Yeah. And 100 life and 50 damage or whatever. Great.
Yeah.
You're saying, how does this thing know that you can actually call this constructor?
Yeah. Because these values right here,
Mhm.
the 150,
Yeah.
aren't going in here. They're going in here first, right?
Well, it's the same. So if you go like,
but this is where they first go, don't
Yeah.
they? Okay.
Yeah.
Because then they're being assigned to. Or isn't this the wrong way around?
no, it's right. It's right.
Okay, but
Health is going to be equal to the health in the class. Is
Oh,
equal
okay,
to
yeah,
A.
yeah, okay.
Mhm.
We're basically just telling you that now the 150 are these two numbers, and that's here.
Yep.
But then how does that go from? Huh.
So it's kind of a loop around, right?
But it goes from here
Mhm.
to here,
Mm-hmm.
then to here.
No. So this,
Yeah.
the header file, doesn't actually run any code.
Okay.
Think of it as a description more than an actual object.
Okay.
I say like there's going to be a chair. It has 4 legs. You can sit on it. It is blue.
But how does it know then what should go and make this chair that shape?
So at this point, from game's point of view, it doesn't. Like
Okay.
if we're only game.cpp, we don't know what the constructor does. We just trust that in the end, there's going to be a constructor that does something. We're going to call it, and then we're just going to hope that whatever code is there is good and makes sense.
Okay.
Yeah. Yeah.
Does it make sense?
The big idea there is that you need to separate out whoever's using the code and whoever implemented and made the code. So it's a case of when you use a clutch in a car, when you push the pedal on the car, do you actually care how that works?
No.
You just know that if you push the pedal, the car will go.
I can change gears.
You can change gears if you use the clutch or the gearbox. If you push the gas, it will just go forward, right? You don't care. And on most cars, it works the same. When you push the gas, it goes forward. You might have to have a condition of like if you're in gear and the car is turned on, and then you push the gas and it goes forward. So that's kind of the idea of an interface, that you don't know, you just trust that it works. And if it doesn't work, it's broken and you need to fix it. So from game CPP's point of view, that there is a constructor, it just says like, oh, it looks like this. It's called enemy. It has the 2 arguments. Again, it's called enemy. Here's the constructor and has 2 arguments. What actually happens when you call it, we don't know yet, at least from the early stages of the compilation point of view. So, but when everything is come together, the 2 object files are combined with a linker. Then,
because the CPP files get combined.
Yes, at the end. Yes.
Okay. So that because I forgot about that because I was struggling with like there's no connection between this one and this one right now.
Initially, no.
They don't talk to each other, so they don't know what each one of them is doing.
Correct.
But then later on, they just go. Whoop!
Yep, they get merged together.
With that exact sound.
Bloop. Yep, and then the actual exe file, the executable file, will contain that. Oh, when you call the constructor, you actually jump to this line here, and then you execute that code. You send in the numbers. There you go.
Okay.
So again, this sounds counterintuitive in the beginning, that you have these 2 worlds. They're absolutely separate. You don't talk to each other. But then at the end, they just, hey, here they are. They're connected. And then you have the description of the class, and it actually happens twice. And in big project, you would have this gigantic hierarchy of files. And that's often why people say that you need to create and build and structure your project well, and create your classes thoughtfully, because when things grow,
is that when you hear games talking about legacy code?
If you have legacy code that like, oh, we used to do it this way, we then found out it's better to do it the other way, but we have this 1 million lines of code done the old way.
Yeah.
So what do we do? How do we work with it? And a way to actually deal with that sometimes is to create another layer. So you have this big blob of legacy code.
We're just like, here's a bigger building.
Yeah, you put something on top of it, saying like, oh, we're going to use it. Here's a newer way to talk to it. We don't have to think about it. but then you can slowly chip away at it over time. We say like, oh, we can't do this all at once. We'll make a prettier interface on top of it. And this thing here, this is an interface. This is how you talk to enemy. And the fun thing is, imagine you have enemy CPP here, right? Imagine if you would make another CPP file called enemy stronger.cpp, where
You could just change.
where we do ×2 and everything. Yeah.
Nice.
Okay. Now it's a whatever you say here is always stronger and bigger and whatever.
It's a rare mob.
Yeah. Look that we never changed this file, and this person here, he does not know about that.
No, I don't know what's around the corner.
No.
I'm gonna be dead.
So there is a way to swap out implementations. Maybe not the best way to do it is to make multiple files. There is another way to do that, which is called inheritance, which we will go into. But yeah, so the important thing to know is we change stuff without changing other files. And when you're compiling, when you say here like, oh, I'm going to make this file, we will compile game CPP, and then we will compile game enemy CPP into 2.0 files and then combine them. If you only change enemy CPP, you're not gonna compile game CPP again. So even if recompiling the entire project will take an hour, let's say that, and then you only change one file, enemy CPP, for example, if you only change that one file, it won't take you 20 minutes to compile. It will take you, I don't know, a couple of seconds to compile, and then maybe a few more seconds to link them all together and make the blob. The blob. So you can, even on a big project, you can work incrementally like this. So, and then if we put a breakpoint here, and then hit F5.
On 6?
Yeah, you have a semicolon in the wrong place.
I do.
Yeah.
I don't know why it's there.
It's okay. Cool. So then you can see that, yeah, we have Gabe. It has health, it has damage.
Aha!
And then if we stop it, and then we go to enemy CPP, and we go and put a breakpoint there, and now we have a breakpoint at the end of the project, and we have a breakpoint in the constructor. When we hit F5,
bam, it goes over there.
And then if we hit F5 again,
bam, it goes back.
It goes between the files.
Nailed it.
Yeah, there we go. So this was a little bit about the project structure.
Nice.
Yeah, sounds good.
Sure.
Sure. So if we swap over to mine, there we go.
No.
And then, yeah, we have, so you can see here, yeah, it's, now this again seems a little bit more clear that you have these two files, but they share the header file. Looks like this, basically. Great. Or, yeah, this is another way of thinking about this. Great. So, homework. It was quite a bit last time, right?
Yeah.
And we have Christmas break coming up.
Yeah.
So what's better than to sit in some nice pillowcases and with your tablet and whatever and watch some YouTube? Yeah. So there is a series called C++ Weekly by Jason Turner. He is a wonderful guy. So a thing I talked about in the first episode is this is one way of learning C++. This won't be everything. God, no, this will take forever if we do it that way.
We're here forever, everyone.
Yeah, that's gonna take take a long time. And I said, like, you should never learn from one source. You should be absolutely soaking information, like trying to learn from everybody, and then make your own opinion in that sense. So he has a series.
Homework is to watch the first 101 episodes of C++ Weekly.
Yeah, exactly. No, so there's his regular series, he has an episode every week. His regular series is just, hey, here's a new feature, etc. He also has Learning Modern C++ series. And then the homework is basically look at them, listen to them, see if he talks about something a little bit differently, see if you learn something from there or if more questions arise. I'm basically forcing you to say, like, go look at others. You need to, like, this here thing, wonderful as it is only a fraction of your entire learning experience. So
just for the people in chat, Oh, actually, we'll do that in the post show. I'll grab the link for the first episode.
Yeah.
And then we'll put that. We'll also put that in the description.
In the doobly-doo.
Yes. As a YouTube video.
Great.
But yeah, we'll be back.
Yeah, so we're Christmas break. We're back in. I think it's second week of January.
Yeah, second week. Though there are some stuff, which I mean, we'll talk about that.
Yeah.
There's some magical things happening in January, which means I might be on an airplane and hate myself because I hate flying.
But yeah, follow the Twitters and
yeah, we'll keep everybody updated. We'll also be in the Discord.
Yep.
So that's where all the updates will be. All those links are either down in the Twitch description or in the YouTube description. But we have some really stupid videos coming up.
They are amazing.
You should watch them. They're going to be good throughout the month of December. But otherwise, we will see you after the break. And hope you have a good holidays.
Bye.
Bye.